In this video, we're going to deduce the structure of C10H12O2. Now, this is the same molecular formula as video number 9, and it's an isomer of video number 9. So again, showing you how you can change the NMR ever so slightly to get your final product. So, if we look here, we're going to look for what is there and what is not there. So starting off, what is there is we've got this benzene in the middle of 6 to 8, which has 5, so it's mono substituted. We've got a CH3 and then a CH2 and a CH2. Okay, and both triplets. Notice there's nothing here between 10 and 12 and nothing here between 9 and 10. That is aldehyde between 9 and 10, carboxylic acid between 10 and 12. And we've got 2 oxygens up there. Okay, so it's good that we've eliminated the carboxylic acid. Okay, it's no alcohol there as well, so we don't have any alcohols because that would be a singlet with a 1 by it. And it's more than likely not going to be a ketone because you don't normally get 2 ketones in one molecule. So I'm thinking, because it's got 2 oxygens, it's probably an ester. So let's do the table, put the data in the table. At this point, let's do our environment. It's 4 because there's 4 peaks. And the triplet means there's n plus 1 equals 3, 3 minus 1 equals n is 2. So that's 2 hydrogens on the adjacent carbons. That means for this triplet with a 2, there is a carbon next to it with 2 hydrogens on it. Now that means there's 2 peaks here, both with 2 hydrogens, which means that these CH2s are more than likely right next to each other. Okay, so there's CH2, CH2. Now, let's take it back though to our molecular formula. We think we've got CH2 because of the relative peak area, CH2. We think they're both next to each other. We've got CH3 and we've got C6H5. We want to check those against our molecular formula and see what's left. We've got CO2. That confirms that we have got an ester like we thought we had. We put everything over to the right-hand side and then start writing out our ester. So, first of all, we know we've got a CH2, CH2. We also know we have got a benzene. Now, we know that the CH2, CH2 is 2 triplets. So I'm going to put T for triplet, shorten that. So 2 triplets. Because that is 2 triplets, that means this carbon here must be bonded to a carbon with no hydrogens on. And if it's bonded to benzene, that carbon right here has no hydrogens on it. So that would make sense. And you have to make educated guesses in NMR. So when you're doing it in an exam or doing it as questions, you have to usually make a few guesses first. And that's my first guess. I'm thinking that's got no hydrogen on it, so it makes sense. This side also has to connect to a carbon with no hydrogens on it. Okay? Or an oxygen, for example. So basically, I'm looking here and I've got CO2. I think my CO2 is going to go in there because the only thing left after that I have is CH3. Okay? So if that is the case, it's how does my ester actually bond to it? Is it the single bond oxygen or the double bond oxygen? So to do that, we have to look at here and we have to remind ourselves of these two rules. So if the hydrogen is on a carbon, this is your hydrogen on the carbon, okay, is bonded to a single bond oxygen, you'll see a peak between 3 and 4.3. Well, there is a peak between 3 and 4.3. So I think that CH3 is bonded to the single bond oxygen. Then we've got two peaks here, which means they could both be this. So they could both be the C double bond O. However, if you look on your data sheet, hopefully you've got your data sheet right in front of you, it also comes out at that area a hydrogen on a carbon bonded to benzene. So one of these is the CH2 bonded to benzene, and one of these is the CH2 bonded to the C double bond O. So I'm going to put the C double bond O, and then I'm going to put there, and then I'm left. I've placed everything. I've placed my CO2, placed my 2 CH2s, I've placed my benzene, I haven't placed my CH3, and so I'm going to place my CH3. And my CH3, remember, is at 3.7, which says the CH3 is bonded to the single bond O. So we've done that all so far. I just want to check that everything is correct. So I'm going to get a multiplet there. Okay, I'm going to get a singlet there. Do I get all of that there? Yes, I do. Okay, then I'm going to get a relative peak error of 5, 2, 2, 3. Do I get it there? Notice in every single video I do a final check just to check that it is correct. Okay, and that is my ester if I use the different ppms for HCO and HC double bond O. Now just to finish off, this is not mark-worthy. And the reason it's not mark-worthy because it says CH2, CH2, CH3. It doesn't tell me which one is which. Now it turns out that these two CH2s are in the same region in the data sheet. So you don't know whether it is the CH2 bonded to this or the CH2 bonded to this. You know there's one of each. So therefore, just pick one. It doesn't really matter. So I've picked one. I've said, look, this CH2 bonded to the CO is the first one. Okay, and I don't have to put the benzene in if I don't want. Because I've chosen that CH2, I can just choose the other CH2. Remember, I'm highlighting it here. You'd probably underline the hydrogen in yours. And that means it's totally unambiguous. Okay, so because it's totally unambiguous, it's worth a mark. Okay, and that is how you complete this question and find out the ester using the different ppms. To summarise, we looked at the two oxygens that were in the molecular formula, checked for the carboxylic acid. We couldn't see this singlet with one by it. We thought it was likely to be an ester. We also did a calculation using the molecular formula and found we had CO2 left. Really important point, again, to look at that 2 to 3 to 4.3. Okay, make sure you remember it. It could be the missing of one mark. Okay, really, really important. And if you look here and we draw our molecules, we know that it's this way because that CH is next to that single bond O because it came out in that area, and this CH2 is next to the C double bond O because it came out between 2 and 3. And that's a really important lesson of the previous two videos.